I'm Daniel, founder of FixedIT Consulting, where we build an ecosystem that makes it easy to make applications for the AXIS network cameras. In this video, we're going to have a look at how we can use our CLI tools to make it easy to build and test and deploy applications to the AXIS network cameras. So let's get started. Developing applications for AXIS cameras like the ones you see here behind me is a bit more complex than developing applications for your local PC environment or cloud environment, mostly because it is more complex to interact with a device. There is a bigger variety between different devices, and you need to SSH into the device which is running headless and so forth. So one of the things that we have been doing here at FixedIT Consulting is to create tools that make it easier to work with AXIS cameras. So our tools work together with the AXIS ACAP SDK that you get from AXIS, and it creates a developer environment which makes it much more efficient for your developers to work with the cameras. So the tool I'm going to show today is our build tool that you can use to build different kinds of applications. So we're actually going to start by going over to the AXIS ACAP native SDK examples. So this is a repository from AXIS with a few different applications showing how you can use the different APIs. And one thing that we will talk more about later in other videos is how you should design your applications to make them long-term viable for real projects. So what you see here in the examples is typically not how you want to design your own applications when you actually build a product, because this is just to keep it as simple as possible to show a single API. But more about that later. So right now we're just going to see how we can actually build one of these applications. So let's, for example, select the XOverlay application. And you can read a README from AXIS, and you see that you should build a Docker container, and then you should create already build a Docker image, and then you create a container from that image. And from that container you can copy the EAP file, the package file that was created, and then you can go to the camera's web interface and manually install the application. But with our workflow you don't need to do this. So instead we're going to start by cloning this repository. And we cd into the XOverlay directory. So what we're going to do now is that we're going to use the fappcli, which is our CLI tool, and one of the tools here is our build tool, which will help you build an application. So all I need to do is to say that I want to build application in this folder. That is what the dot means. And when I run this, it will automatically detect what kind of application it is, how the Docker file looks like, build a Docker file, which also builds the application. And it has now extracted the application from the Docker file. So we have the application here now in my local directory. So already here we have reduced a few steps, which make it a lot easier. The next thing we want to do is that we want to install it in our device. So there we have the CLI tool for deployment. And one of the commands here is install. And we're going to install the EAP file that we just built. So if we open the browser again and head to the camera, the application page, we can see that we now have the XOverlay application installed. And of course we can see that this is the regular image. If we start the application, we will get an overlay on top of the video. So this makes it a little bit easier to install applications. Let's delete this one again. As we did now, we did this in 2 different steps. We first built the application and we then installed the application, but we actually don't need to do that. We could instead run the install command, and instead of pointing at the EAP file, we point at the build directory, and this will automatically build the application for us. Another thing we can do is to run it interactively in the terminal, and for this we have the deploy run command, and this can also build application for us. So this will automatically select the camera for us. We have multiple cameras connected to this computer, so you can see here that we selected a 092 camera. The reason for this is that it just randomly selects one of the available cameras. Instead, what I can do is to use the fappcli-deploy list command. This will now list all the cameras that is connected to this particular computer and the status of them. So we can see that the camera that we was using here was this TPU camera. And all of these has different architectures, which the tool will automatically detect and build for the right architecture. So if we will now want to use the same camera, we can do the fappcli-deploy run this directory, and we want to specify the camera named cam TPU. So we make sure that we actually use this camera that I'm logged into in the browser. So as we can see now, the application is not installed. If we go back to image and we run this command, it will automatically build the application for the correct architecture that this camera is running. It will then check if the application is installed. If it isn't installed, like in this case, it installs it for us. If it was installed, then it will just update the files that have been changed since we installed the application, which make it a bit faster. And then it goes and interactively runs the application. So we can see here that this is the actual output from the application itself running in the camera, and we can see that it also shows the overlay in the video interface. So if I Ctrl+C this, we see that the application stops to show the overlay. And we can of course also see that the application has been installed in the camera now again. So then you might wonder, how do we actually configure the cameras? And for this we have the config tool. And here we can list our configuration file. So the configurations are collected from multiple places. First off, you have a location in your home folder, which contains a config file. And then it can be overridden from different places. So we could have another config file in this particular directory, which only applies if we are building in this directory. Or we could specify overrides on the command line. And all these configurations is collected to create the combined configuration that we're using. So here we can see that we have multiple cameras configured. We can use both the IP address on our local network, but since I am often working on my laptop remotely with not direct access to the cameras, I also want to be able to work with remote cameras which are available through an SSH tunnel, for example. So to do that, I can instead specify an SSH host name, and it will then use my SSH keys, which should be installed just like when using normal SSH. I have now moved over to my travel laptop, which happens to be a Mac. And then there are a few different things that differ when working on this laptop compared to working on my workstation. And the idea with the build tool is that it should abstract and handle all these differences. So it will be as easy to build regardless of where in the world I am and what computer I am using. So one of the things that differ is that this Mac happens to have an M1 processor, so an AMD, an ARM64 processor. And the AXIS SDK images are only distributed as AMD 64 container images, which means that all the compilation on this device will happen virtualized, which means that compilation will be very slow compared to compiling natively. We're not going to talk more in this particular video about how we can solve this, but we're instead going to focus on the second of the issues, that when I'm out traveling with this laptop, I don't have direct access to my cameras. My cameras are connected to another network than the network I am currently located at. And this is also a thing that the fappcli-build tool, or rather the fappcli-deploy tool, handles for us. So there are a few different ways we can deal with this. Firstly, we could use a VPN service to VPN into the same network that our cameras are located at. But I'm not going to do that here. Instead, I'm going to use SSH tunnels. So what we have is a server in Amazon, which acts as an AWS gateway, or an SSH gateway, which the cameras connect to, and which we then can use as a proxy jump. And all this is configured using plain SSH. So if I switch over to my screen here, you will see that I have my SSH config files, which specifies the different cameras I have, and it specifies a proxy jump host. And this proxy jump host is specified here as an AWS server. This means that we can access the cameras using SSH. And since the fappcli tool can handle SSH connectivity without having direct access to port 80 or port 443 in the cameras, we can make use of the fappcli tool anyway. So I can list all my devices, and we can see that I don't have any direct access to any of the devices, but I have SSH access to them, which means that we can perform all the activities that we want to do over SSH. But sometimes we want to access port 80, for example, to use the web interface, and then we can make use of the fappcli-deploy proxy command. So if I just run this without specifying any specific camera, it will randomly select one of the cameras that is currently in OK status, and it will SSH to it and create a port forwarding. But we can see that in my configuration I have not specified any credentials. We can actually abort this, and we can have a look at the configuration. So here is the list of different cameras, and we can see that I haven't specified any username or password for any of the devices, and the fappcli tool can handle this. Since we have SSH access using my SSH keys, it will automatically create a temporary user for us with a temporary password. So at the same time as proxying device, it will create this for us. So if we yet again open the proxy, we can see that we can connect to this device, and we can log in with this temporary username and this temporary password. And although the proxy command can be used to manually create a proxy forwarding connection, to access the camera. We don't need to do that when installing or deploying or running an application. That will be done automatically for us. So we can see here that we have access to the camera. So if I now stop this proxy, I can do fappcli run, which will build application, it will install the application, and it will run the application. And we do it in this directory. Sorry, it should be like this. So in this case, we actually also need to specify that we are using libfapp. We could do this for a configuration file for this project. In this case, I haven't done it. And here we can also see what I was talking about, that the SDK images are AMD 64 images, but our CPU is the ARM 64, which makes the compilation process significantly slower. So we can now see that the application has been built, and since we only have SSH access to the camera, it will automatically create a port forwarding to access the Vapix APIs, and then it will use the Vapix API to install the application, and it will start the application. So this output line is actually the standard output from the application running in the camera. So this makes it very easy to work with cameras while being remote from my laptop and not having access to the cameras. And also if you have a shared server with multiple cameras connected, this will also make it easier to collaborate in that sense. So this was a bit about the build tool and building a simple application from AXIS. But this is just a fraction of what you can do with the build tool. So the build tool does a lot more things. So at FixedIT Consulting we have different libraries that are pre-built for the cameras. So when we're going to create an application that makes common tasks like HTTP push, for example, or serving a web page from the application, then we don't have to rewrite all the code. We can instead use our pre-built libraries that are hosted in a repository. And the builder tool will automatically authenticate to this repository and download the libraries needed. And we do this by using a token that you will get from us. And we also have the ability to build bake files, so docker build x bake, and the main benefit of this is if you have multiple applications that share a lot of code together, then you can build that code separately, and the bake files can specify multiple docker files that should be built with the same build, and this will not only make reuse of code a lot easier, it will also significantly increase the build speed. So that is one of the patterns that we recommend if you're going to build production grade applications that you can't find in the AXIS examples. It also has information about the cameras, like different library versions and what architecture it is using and so forth. Which means that if I want to test my application for the ARM v7 chip, for example, or let's say the CV25 chip, then I can just specify that on the command line. I don't need to say which camera I want to use. I just specify for the builder tool that I want to run this on a CV25 camera, and it will automatically find a camera that is configured and ready with a CV25 chip and build the application for that architecture, install it in the camera and run it. So it makes camera handling a lot easier. And it also takes care about license information from the different libraries and so forth to make all these things easier that you're commonly always doing when you create production grade applications. So this was a bit about the builder tool. You can also find an example on our GitHub. We have the AXIS ACAP guides where we have a few different examples that are in a public repository, so you can access it without being a customer of ours. And here you can find one example which is a FixedIT application, hello world, so a minimum application that is using our libfapp, which is our standard library. So with this library we can make a few common tasks much easier. So for example, we have a predefined signal handler which handles a lot of different signals to make the application clean up in a graceful way and release any resources needed and so forth. And if you're using the glib event loops, then you can easily register the loop in your event handler to actually stop the event loop and stop the application when a signal is received, for example. And it also takes care of the logging in a way that is make it easier to debug, easier to run from the terminal and so forth. Another key to creating high quality software products fast is to make use of CI/CD, continuous integration and continuous delivery. And this is something that you won't find in the AXIS examples, but our tools make it very easy for you to make use of CI/CD. So you can use the same fappcli tool in your GitHub Actions jobs, for example. And we can see an example of this if we go to the root of this AXIS ACAP guides repository and we go to the GitHub workflows directory. Here we can see two different applications that are built with CI/CD. So if we go to the Hello World application using libfapp, we can see that we make use of the fappcli, but we're actually not using the command line tools directly from the run sections in GitHub Actions. Instead, we have created these different actions, which you can find publicly on our GitHub repositories. So what we first do here is that we create a matrix and say that we want to build our application both for the ARMv7HF platforms and the AArch64 platforms. And then we create or install the fappcli tool and log in, and we use our fapp token for this, a token that you will get from us when you're working with our products. And this step will install the tools in the CI/CD job. So next we can use the build EAP actions to actually build application. So we specify which architecture we should build our application for. We specify which directory the source code for the application is found in. And we specify any libraries that should be used in the building process. So in this case, our foundational libfapp. And after we have built the libraries, we of course want to verify that the application is actually working and will be installable in our camera. So to do that, we have the test EAP action, which use the test command in our fappcli tool that we didn't cover in this video. But essentially it goes through the content of the EAP file and verifies that it's built for the correct architecture and that the integrity of the file looks good, so you haven't forgot any files that should be in the package or stuff like that. So this will significantly improve the speed of the development cycles compared to having to test everything manually, and it of course reduces the workload in code review, since a lot of the mistakes will get caught by the CI/CD job instead of having to be pointed out by another developer reviewing your code. So this is also something that we recommend all our clients to do to implement CI/CD for their applications. So we have looked at a lot of different tools in this video, and we have seen how it can help you be more efficient when building applications, when testing the applications on the device, and when building CI/CD workflows to improve the building pipelines or the review flow for your applications. And we have also seen how you can be more portable, working from any computer, any place in the world, with as much efficiency as possible, by being able to access the cameras transparently without thinking about where they are located or how the communication to the cameras is actually performed. So these tools will make you a more efficient ACAP developer. These tools are available to our clients. So if you become our client, we will help you get started using the tools. We will help you adapt applications that you already have to work with the tools, or adapt the tools if that is needed to work with your applications or your specific needs. So with these tools, I am sure that you will become more efficient. Sounds good? You can always reach out to us by filling in the contact form on our webpage. You find it at fixedit.ai, and you can fill in the contact form, or you can contact me directly through LinkedIn or through an email. I'm always interested to hear about your specific use cases and how we can help you.